In this second video, we're looking at the coordinates of triangles and quadrilaterals and trying to determine what kind of triangle and what kind of quadrilateral it is. So we will first look at triangles. And the question we're asking ourselves is this triangle scalene, isosceles, or equilateral? Now, just to remind you, scalene means that none of the sides are the same length, or all the sides are different lengths. Isosceles is where two sides are the same length, and equilateral is where all three sides are the same length. So, looking at this picture, I ask myself, could this be equilateral? And to me, the answer is no, because AC looks much longer than AB. Okay, so it couldn't be equilateral, but could it be isosceles? Well, possibly. Okay, AB and BC look to be similar in length. I can't tell by looking at the picture, but I'll need to find the distance or the length of AB and the length of BC to figure out if it is isosceles. Okay, so I'll use the distance formula. So for AB to figure out the length of AB, I will call this x1, y1. And x2 and y2. Okay, plugging it in to the distance formula, I get 4 minus 0 squared plus 4 minus 1 squared. Okay, 4 minus 0 is 4 squared. 4 minus 1 is 3 squared. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. And I get 5 as my answer. Okay, so this length is 5. Okay, BC, x1, y1, x2, y2. I get 7 minus 4 squared plus 0 minus 4 squared. 7 minus 4 is 3 squared. 0 minus 4 is negative 4 squared. 3 squared is 9 plus, be very careful with negatives in the distance formula. Negative 4 times negative 4 is a positive 16. Okay, and so both lengths are 5, and so it is an isosceles triangle. Okay, next question. Graph and label each triangle with the given vertices. Determine whether the triangle is scalene, isosceles, or equilateral. Then tell whether each triangle is a right triangle. Okay, well, I look at this triangle and say, could it be equilateral? And to me, the answer is no, because our eye looks much shorter than the other two. Okay, the question is it isosceles? And it doesn't quite look isosceles, but it might be, because TR and TI, these two, look to be similar in length. Okay, so I use the distance formula to find the length of TR and the length of TI to see if it is isosceles. Okay, I'll begin with TR. So I'll call this x1, y1, x2, and y2, and plug it into the distance formula. Okay, now I could find the decimal for that, but that's sufficient for what I'm doing now. So TR is the square root of 53. Now to find the length TI, I will call this x1, y1, and this x2, and this y2. Okay, so the square root of 34 and the square root of 53 are not the same. Okay, so like I thought, this is actually scalene because all three sides are of different length. So it's scalene. Okay, now the question is it a right triangle? It doesn't look like a right triangle, but just to check, or to check, I will see if two of the sides have slopes that are negative reciprocals of each other, or their product is -1. Now, if this were a right triangle, it doesn't quite look like it, but if it was, I would guess that I would be where the right angle is. Okay, so I'll find the slope of RI and the slope of TI and see if they are negative reciprocals of each other. So the slope of RI, I'll call this x1, y1, x2, y2. It's y2 minus y1 over x2 minus x1. 4 minus 8 is -4. 6 minus 3 is 3. Okay? Now, to find the slope of TI, same formula, y2 minus y1 over x2 minus x1. I get 5 over, I get 3 over 5. Okay, now these two slopes are not negative reciprocals of each other. I couldn't take one, flip it over, change the sign, and get the other one. And if I multiplied them together, I don't get -1. Okay, so these are not perpendicular, and this is not a right triangle. Okay, and that's it for this one. Let's move on to quadrilaterals. Is this parallelogram a rhombus? Now, typically, in a question about is this a rhombus, I'd find the lengths of two adjacent sides to see if they're the same. Okay, but in this case, they've drawn in the diagonals for me, so I'll think about what do I know about the diagonals of a rhombus, and the property that comes to mind is the diagonals are perpendicular in a rhombus. So I will find the slopes of these diagonals and see if they are perpendicular. Okay, so I'll begin with the slope of BD. So slope of BD, I'll call this x1, y1, x2, y2. And again, the equation is y2 minus y1 over x2 minus x1. Zero minus 4 is -3. 2 minus 0 is 2. So the slope of this is -3/2. And in the other one, I will find the slope of AC. I'll call this x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. Now x1 is a -2. So 5 over 4 minus a -2 is 4 plus 2, or 5 over 6. Now, are these two slopes, are they negative reciprocals of each other? No. I can't flip one over and change the sign and get the other one. And if I multiply them together, I don't get -1. Okay, so this is not a rhombus because the diagonals are not perpendicular to each other. Okay, next question. Determine whether the parallelogram is a rhombus, rectangle, square, or none of the above. Okay, now I've already graphed it for you. L, M, and P is over here in green. Okay, now looking at it, it doesn't look like a rectangle because the angles don't look to be 90 degrees. And it doesn't look like a square. It looks like a rhombus. Okay, and I will check a rhombus to see if it's a rhombus by finding the lengths of two adjacent sides. Okay, so I'll start off with LM, and I'll find LM. I'll call this x1 and y1, x2 and y2, and plug it into the distance formula. Two squared is 4, 1 squared is 1. I get the square root of 5. Okay, so that's 5. To the square root of 5, okay? And because it is a parallelogram, they tell us it's a parallelogram, and so the opposite sides are the same length. That saves me some time. Now, I will find the length of MN, okay? X1, Y1, X2, Y2. Oops, squared. Okay, be very careful with negatives. Negative 1 squared is negative 1 times negative 1, which is a positive 1. And I get the square root of 5, okay, which sounds familiar. That's what I got over there. So this is square root of 5, and since it's a parallelogram, the opposite sides are congruent. Okay, and all the sides are the square root of 5, and so it is a rhombus. Okay, and you can also see that the diagonals are perpendicular because they're horizontal and vertical. Okay, this quadrilateral, I've already graphed it for you in blue. So in this question, we're trying to determine give the most precise name for this quadrilateral. Well, looking at it, it looks like a trapezoid. Okay, and we can tell that it is because QR has a slope of 0 and PS has a slope of 0. That was pretty easy. But the question is it an isosceles trapezoid? Are PQ the same length as RS? Okay, and we could use the distance formula. Now, for the sake of time in this video, I won't, but we could find the length of both of them, and if we did, they'd be the same, and it would be an isosceles trapezoid. Okay, determine the most precise name for this quadrilateral. Okay, I've drawn the points, and it looks to be like a kite. Okay, and even the diagonals are perpendicular, they're horizontal and vertical, as a kite should be, and these look to be the same length, and these look to be the same length. Okay, and I could use the distance formula to check this. Okay, and I probably would on a homework assignment, but for the sake of the time in this video, I won't. But you could use the distance formula to double check that this is a kite. Okay, the next type of question that you'll be asked is to find the most precise name for the quadrilateral formed by connecting the midpoints of the sides of some shape. Okay, so I'll find the midpoints, and I could use the midpoint formula to do this, but I'll just kind of look at the graph and kind of guess. Now, it's important you have a clear graph to determine this. If your graph isn't very clear, you may need to find the coordinates of the midpoint using the midpoint formula discussed in the last video. Okay, now looking at this green figure that I've drawn in, okay, it's pretty clear that these are all 90-degree angles because they're horizontal and vertical. Okay, and so the shape here is a rectangle. Okay, last problem is what's the most precise classification for this quadrilateral below? This is a rectangle, and if I draw on the midpoints, okay, now it looks to be a parallelogram because the sides look parallel, okay, but it could be a rhombus because the sides look to be, close to being the same length. And to check that, I will find the distance of the sides, specifically two adjacent sides. So this coordinate right here is -1, 1.5. This coordinate is 1, 0, and this coordinate is 1, comma, -2.5. Okay, so this length right here, this distance, I will call this x1 and y1 and x2 and y2. One minus a -1. One minus a -1 is 1 plus 1, or 2. Okay, be very careful with negatives. 2 squared is 4. -1.5 times -1.5 is a positive 2.25. Okay, and I get the square root of 6.25. Okay, now to find the length, this length, since it's perfectly vertical, I don't need to worry about how there's a change in x because they're both 1. So I'll just kind of take the difference between the y coordinates and I get 2.5. Okay, now I can't really tell if those are the same or not because I have the square root of 6.25, so I'll find the decimal of that. Square root of 6.25 is 2.5. Okay, so these sides are the same length, and because it's a parallelogram, the opposite sides are the same length, and so it's a rhombus. Okay, so I hope that by now you can use the distance formula, as you'll have lots of practice of it in this section. You can use the midpoint formula to find midpoints on a segment. That you can use the slope formula to find the slopes of segments, and also remember that segments with the same slope are parallel. Segments with perpendicular slopes the slopes will be negative reciprocals of each other. And I also hope that you can determine if a triangle is scalene, isosceles, or equilateral, or if it's a right triangle or not. And that you can also determine if a quadrilateral is a parallelogram, rhombus, rectangle, trapezoid, kite, isosceles, trapezoid, all the different kinds of quadrilaterals that we've discussed in this chapter.